Alright, in this video lesson, we'll be introducing radians. Up to this point, we've taken a circle and we've broken it up into a random amount, 360. And each of these pieces we call the degree. You're most comfortable with saying there's 360 degrees in a circle. But as we begin to look into this video, we'll see that 360 is pretty random of a number to use. So we'd like to consider breaking it up, a circle, into a certain amount that's at least relative to the circle. So this is where radians come into play. What we'll do, we'll start with a circle and we'll just identify the radius. And we'll take this linear amount, the radius, and we'll stretch it along the circumference of the circle, along the outside of the circles. So this distance here is the same distance as the radius. And this distance stops at this point. And so if I hooked another radius there, we have an opening. This angle opening right here was defined by the distance of the radius. So three different radii, radius the length, radius the length. The opening was defined by the radius. This opening is called a radian. So we begin to, see an opening that is relative to the circle. The opening is defined by a component of the circle, the radius itself. So just like degrees, I can go around the circle and continue breaking it up into various amounts. And each amount is another radian. So I continue to stretch my radius along the perimeter, along the circumference of the circle. So at first sight, when you look at this, it doesn't seem like this would be a reasonable amount to open it up because it doesn't even go all the way around. So we'll be looking at that on the next slide. But prior to that, I just want to look at a couple, some fundamental things with radians, specifically the symbol. The symbol, just like degrees, has a particular symbol. Radians has its own unique symbols. First symbol is just the word RAD, short for radian. So like 3 radians. The other symbol is this little C. Now, it's rarely used, but I just wanted to present that there is a symbol for radians. So 3 with the little C stands for 3 radians. The most common is to put nothing. So if you're referring to an angle and you're speaking about it being in radians, there's no symbol that you would typically use. So if there's nothing there, it's assumed to be radians. So what we'll begin to do is look at how many radians are there in a circle. Same way you're able to answer how many degrees are in a circle, 360. We want to explore how many radians actually are in a circle. Well, we can redefine this question and basically ask, well, how many radians are in 360 degrees? And what this will do is to help us to begin to develop a strategy from converting radians to degrees and degrees to radians. So we'll start with our circle and we'll create our first radian. And again, because the radian was defined by the radius, what I'm simply going to do is just wrap our circle with a bunch of radii. So as it goes around the circle, we begin to look at the number of radians based upon the number of radii. So I can redefine my question again. Is I want to know if I'm asking how many radians make up the entire circle, I redirect my focus to the outside and restate, well, how many radii will make up the entire circumference? So they are synonymous. Well, if I look at it right now, it's obvious to see that there's 6 plus there's this little section right there. So if you was to be asked, well, how many radii make up the circumference? I would say a little more than 6. Well, that's kind of an estimate. Let's see if we can come up with something a little bit more accurate. Well, if we wrapped the radii around the circumference, let's bring our attention to the circumference. The formula for circumference in geometry was 2 pi r. And what did the R stand for? R stood for radius. So now we see this connection. There's our circumference, and it's wrapped with a bunch of radii. So if we took the circumference, 2 pi r, and split it up into a bunch of radii, we would be left with 2 pi. 2 pi, that's a real ambiguous answer. You're like, well, what the heck is that? You're telling me that there's 2 pi radii? Well, what is pi? Pi is an actual number, approximately 3.14. So when I multiply 2 times 3.14, I get 6.28. And guess what 6.28 is? It's a little more than 6. Meaning this, when we looked at the circle, we could see that there were a little bit more than 6 radii. When we did the actual value and divided the circumference, 2 pi r, by r, we actually got an actual number, 6.28, which is a little more than 6, but it's exactly 2 pi. So we're using pi as a number that helps us to tell how often something occurred. So if we look at it, we're saying that there are 2 pi, a little bit more than 6, there are 2 pi radians in 360 degrees. Now if I took it to the next level and actually divided both of these numbers by 2, I would get pi. There's pi radians in 180 degrees. And that should make sense because we're taking half of 360. If half of 360 was 180, half of 2 pi is pi. And if we look at the picture, that's a little bit more than 3 radii to make up half the circle, 180 degrees. We can take one more level, and if I divided both of these numbers by pi, I'd be left with 1 radian, 180 degrees divided by pi. So it's these three phrases here that begin to help us make a conversion or connection between radians and degrees. So I'll summarize everything that happened so far. First thing is just understanding what a radian is. A radian is the opening defined by the distance of the radius. Hence, that's why we call it a radian. It's not by accident. So again, the radian is simply the opening defined by the distance of the radius wrapped around the circle. The other thing we want to take from this is essentially that 2 pi radians is 360 degrees. And I wrote it 3 different ways. First with the symbol RAD, and the most common without any symbol. So generally speaking, 2 pi, 360 degrees. 2 pi radians, 360 degrees. Next, when we took half of it, that meant that pi radians gave us 180 degrees. So just like here, 2 pi, 360, pi is synonymous with 180 degrees. And the last bit of information was knowing that 1 radian is actually 180 degrees divided by pi. Again, if we took this 180 here and we split it by 3.14-ish, 3 and a little bit more radii, you'd be left with this opening. So these are the 3 bits of information that we will be applying as we begin to convert degrees to radians, which will be in the next video lesson. So hopefully this helps.